so the last page of our note packet today is where we're going to be at. And so we're at 3-8, which would have been unions and intersections of sets, right? We did this yesterday. And the very last part here should start with problem 3 and making a Venn diagram. And I have it zoomed out right now because we need this actual color picture to do it on here, okay? So a Venn diagram is like what we talked about yesterday, where we have the circles that intersect each other. And so we talked about those yesterday, and like maybe made them in elementary school to compare each other or things that they have in common, right? And so in this case, it says there are 3 friends going camping. The items in each of their backpacks form a set. Which items do all 3 friends have in common? So in order to be able to do this, let's see if I can keep this on screen. And maybe I'll do this. And I'm trying to cover this up at the same time, which is working out great. So here we go. All right, so here's your 3 friends. This is the pictures in color so that you can see them a little bit better. So to do a Venn diagram with 3, you've got to make 3 circles. So what we want to do is, if you have enough space here, you want to make 1 circle that intersects another one, just like normal. And then that 3rd circle kind of comes around and intersects both of them like that. Ooh, that circle's a little lumpy. Sorry about that. Okay, so to distinguish each one, right, in the picture, you got to kind of look. This is going to be our yellow bag. You want to label that, right? And then let's make this guy our blue bag, and this bottom one our red bag. So when you make a Venn diagram, you want to label each circle that you've got, and then you want to start putting items that they have, right? So in order to do this, we're going to have to, and maybe I'll do this. Maybe I'll move it like this so that I can get both of these on at the same time and zoom in. Woo. Hey, hello. Okay, so let's look at items in the yellow bag, right? So what is one item that you see that is in all 3 bags? Malcolm. A hat. A hat is in all 3. So all 3 has to go in the middle. I'm just going to put H for hat because we don't have a lot of space. Is there anything else that anyone sees in all 3 bags? Carla, what is it? Water bottle. Yep. Okay. There's actually one more thing. It's not as obvious that is in all 3 bags. A map. A map. There's a map here, and a map here, and a map here. Yeah, that is crazy. Okay, is there anything that 2 of the bags share, but not all 3 that you can see here? Go ahead, Joe. The first aid kit. Who shares the first aid kit? So red and blue has the first aid kit. I'm going to put FA. But the yellow doesn't have it. So it's shared there. Is there any other things that are shared by 2 backpacks, but not all 3? Cameron, go. The pan. What 2 have the pan? Yellow and the red. The yellow and the red both have a pan. So I'm just going to put P for pan. There is one other item that I'm not sure if you can see it really well that is shared on here. Okay? There's one other item that's shared. Does anyone see it? What is it? Oh no, I'm lying. I'm looking at the panhandle. Okay. There are not any other items that are shared. But what else is in the yellow bag? Oh yeah, that is not shared with anything. Sunglasses. So we put that here, where it's on the yellow, but it's not shared with anything. Is there anything else on the yellow bag that is not shared with anyone else? shared with the other two bags? Camera, yeah. The old school camera. Okay, not super old school, but. All right, is there anything else in the blue that's not shared? No. All right, how about the red? The rope. Okay. So the only other thing that sometimes we want to make sure we have, so this is the correct Venn diagram, is sometimes you want to put it in a frame, right? And the frame is everything in like the camping world, and we would call that frame the universal set. Are there more camping supplies that you might have, but are not in any of these bags? Yeah, there are, right? So you want to make sure that when you do a Venn diagram, you're saying like, okay, this is the samples that we are talking about. However, there are more things, and that's in the universal set of, let's say, camping supplies. All right, so that's the first thing I have to teach you today, is how to make those, which many of you already knew that. We just haven't put it in a term of algebra of like what's right and what's wrong, and so you've done these before. All right, the harder part, I would say, today is the next part. So I'm going to take away this book so that we have a little more space. And that's problem 4 and 5. Ooh. All right. So problem 4 says, let's see if we can zoom that in a little bit more. All right. So it says this. Of 500 commuters polled, some drive to work, some take public transportation, and some do both. 200 commuters drive to work, and 125 use both types of transportation. How many commuters take public transportation? Okay, so it says we want to use a Venn diagram up here to be able to do this. So let's do this. We're talking about 2 or 3 things this time. 2. So we only need 2 circles. The 2 different things we're talking about is people that drive to work, right? And people that take public transportation. In the middle is the people that do what? Do both, right? Okay, so how many people drive to work, does it say? How many drive? Yes, 200 right here drive to work. 200 you drive to work. Okay. 500 are total, right? And how many people use both? 125. Okay. So if you think about this, right? What do we do to figure out how many people, so it says how many commuters take public transportation? Okay, we have to subtract, right? What if our 500 is total, and it says 200 drive to work, then how many, and 125 use both, how many would be left that use just public? Okay. Now, many of you were able to do that in your head, but what was the math? Some of you added this, right? 200 plus 125 first, and you got what? And then what did you do? Sorry, 175. And that's what you did. Could you have done 500 minus 200 minus 125? Yes, you could have done that as well. Okay, so this is an easier question than it appears, isn't it? The problem is that it's asking you to do a Venn diagram. Don't let it confuse you. Use your logic, okay, when you can. All right, so that's that one. The last one is where our challenge is going to be, okay? It says, what are the solutions? Well, of 2x minus 1, the absolute value is less than 3. Back to that again. Write the solution as either a union or an intersection of 2 sets. So a union means everything in both, right? An intersection means where the two cross over, right? So first of all, before we talk about this, let's solve it. So do I need to split this right away? Yeah, let's go. 2x minus 1 is greater than negative 3. I'm doing the negative side over here. I flipped it. And then 2x minus 1 is less than 3. I left that one the same. Why did I flip this one? Because of the negative. Okay, let's solve it. Add 1 to both sides. So now on this side, I have 2x is greater than negative 2. If I add 1 on both sides here, I have 2x is less than 4. And then the second step for us is to divide. Good. Divide by 2. X is greater than negative 1. And then if I divide by 2 here, I get x is less than 2, right? Now, how do I figure out if this is an and or an or? You graph it, okay? So we graph it. So let's go ahead and make the graph. So on this one, negative 1, 0, 1, 2, I have an extra space, so I'm going to do 3. All right, so negative 1, is that an open or a closed circle? Open. And then 2 is also open, right? Are these going to connect, or are they going to point outward? They're going to connect. All right, now think about this. Do you think if they connect, is that a union or an intersection? It's an intersection. A union, if we give an or and they go outward, that's going to be a union, because you got to do this side of all the ones going this way and all the ones going this way. If it's an intersection, right, it's going to connect. That's an and. So and, maybe we write this down. Ands are intersections. Okay, ors are unions. Okay, and so the way we write this, if it asks you to write it as an intersection, is you write it like this. You would say, let's make our bracket, x, let's do our variable, because that's our x. And then we would do the first answer. X is greater than negative 1. That was our first answer. Intersect, this is the symbol for intersect, right? Like the N shape. And then you do the other one in a bracket. X is less than 2. Intersection. Sorry, I ran out of space. This is literally just a different way of writing it, right? Normally, if we were to write the and, we would put it back together and make it just one inequality, right? A compound inequality. This is another way of writing it. Instead, you can write an and or an or using an intersection or a